Hi, in today's video we're going to take a look at installing Podman on FreeBSD, and we're going to use this to install searxng, which is your own private search engine, and we're also going to set up mcp-searxng-enhanced. And what I've done is actually create a FreeBSD fork of this, and what this is used for is so that you can connect your LLMs running locally or in the cloud to searxng to give them web access to expand their knowledge. And what we're going to be doing is actually setting this up with emacs gp-tel, and this is a client for Emacs that allows you to interact with sort of models running locally or in the cloud. And the advantage of this is that you have a org file where you can type in commands and stuff as opposed to using the terminal. So what I'm going to do is actually go through and show you how to get this set up. So we're going to set up Podman, and what this will allow you to do is run FreeBSD containers as well as Linux containers. I'm actually going to take you through some of the steps that aren't outlined in other sort of tutorials that are floating about that you'll need to know to get this actually working with Linux containers, because there's a few gotchas. So I'll switch across to Emacs and my notes. And first of all, the important distinction between Podman on FreeBSD and Linux is on Linux you have what's called rootless containers, rootless Podman. And as the name suggests, that means that you're running Podman without root access, whereas on FreeBSD we have to run rootful containers, and that means that we have to run the Podman command as root using sudo or doas. So what I'm going to do is actually come through my notes. So here's some resources that I came across that gave me a head start. And the important thing is, for Podman, it has got several packages, and the two that you will actually want to install are Podman Suite and py311-podman compose. And Podman Suite installs most of the Podman tools you're going to need, but Podman Compose is used with compose files that are used to build the Podman containers. So that's the first step, is to install these two packages. And I'm using doas throughout this guide. And the reason why you're actually going to want to set up doas will become clearer later on, is because you can actually set doas to run without prompting you for a password, either for any command you execute or a particular command. So I'll be covering both of those. So for instance, it will allow you to execute the Podman command without being prompted for a password. And this is actually going to be needed because when we set up the MCP server with emacs gp-tel, we don't want to be prompted for a password within Emacs to do this. So that's the first step, is getting the packages installed. The next thing you're going to need to do is actually edit your fstab. So obviously that's doas vi etc fstab. What you're going to need to do is actually have this code here, fdesc dev fd fdescfs read write 00, and then what you're going to do is actually mount that. So the proc is actually required for Podman to work correctly, and you will also need to set up things like the Linuxulator on FreeBSD so that we can actually run Linux containers. So If FD is not mounted, you can mount it like this. Otherwise, what you do is you edit your fstab, you add in this code, and then you mount the proc. Okay. The next thing that you're going to want to do is enable Linux compatibility at boot, and you can do that with doas sysrc linux_enabled equals yes. And then what you want to do is start the service and load the 64-bit Linux kernel module by running doas service linux start, and that's only required during the initial setup. Once you've enabled this command here, it will be enabled at boot, so you won't have to do it every time. And then what you're going to want to do is run doas kld load linux 64, and you're going to want to ensure that it loads at every boot. So what you do is you run doas sysrc kld_list plus equals linux 64, and what that will do is that will edit your etc sysctl.conf. Is it ctl? No, it's sysctl. Hang on, let me just check. Sysctl.conf kld. No, it's the other one. It's the rc. My bad. Etc rc.conf. So what you'll see is we have our KLD list here with Linux 64. So we've got Linux and Linux 64. And down here we have Linux_enabled equals yes. Okay, the next thing you're actually going to want to do is set up the pf config. So you're going to want to enable pf, which I presume you've already got set up. But if you haven't, what you do is service pf enabled, pf start, and what you can do is you can set that in your bootloader.conf. So that would be pf_load equals yes. Then you would run kld load pf, and this is only required while you're setting this up. Once it's set up in your bootloader.conf, it will be ready to go every time you boot up. Now the next thing you do is there is a sample file for podman that is used with the pf config. Okay, so what you can do is run cp user local etc containers pf.conf.sample copy that configuration file into your current directory. And what we're going to do is actually have a look at the pfconf.sample code that it gives you. And what you need to do is actually add this code to your pf configuration, and it has to be added in particular sections. The pfconf has various sections for where you define your interfaces, where the NAT goes, where the anchors go, the tables. So if we have a look, okay, so what I'll do is actually just come across to my etc pf.conf. Okay, let me just port and see. So first of all, what I did in a previous video is show you how you can set a Lago failover device. And this is a virtual interface that combines your Ethernet and Wi-Fi network interfaces into a new virtual interface called Lago. And what this allows you to do is actually switch between Ethernet and wireless without having to change your pfconf, because obviously they have separate interface names. So if you were to change between your Ethernet and your wireless, you would have to edit your pfconf to specify the int interface. Okay, so that's the sort of default interface. So what we're doing is we're setting up the Lago failover device, and what you'll see under here is we have v4 egress if Lago and v6 egress if equals Lago, and these are for podman. So what this allows us to do is actually have this set up so if we're on Ethernet and we switch to wireless, we don't have to go through and change the network interface in multiple places inside the pfconf, which be extremely irritating to have to constantly change your pfconf every time you switch between Ethernet and wireless. So that's why I would strongly advise setting up the Lago failover device. Then what we have here is the VPN interface, which I actually showed you in a previous video as well. We have all networks VPN. We've got our TCP services here, and what we have in the TCP services, the important one is we're actually going to be opening port 8080, and that's going to be required for the searxng podman container, which will run the private search engine, because that's the port that it actually uses. Okay, and we've got some more stuff down here. We have the tables. Okay, we have the global policy. So as I said, with PF, the order of the file is critical, and you have to add the particular bits of code in the right section, otherwise it won't work. So for example, as you can see here, we've got the set block policy, and what you'll need to do is actually add this one here. What you'll see is set skip on LO0 and CNI podman 0, and this is so that we can actually forward the traffic from podman. And this is actually carrying on from a previous video I did where I showed you how you can set up unbound DNS server with DNS encryption and Quad 9. So I'd advise you to have a look at that one to get up to speed. And then what we have down here is NAT on jail. So this is set up so that if we have a jail set up, we can NAT the traffic from the jail. And as you'll see here, we have the NAT on v4 egress interface and the NAT on v6 egress interface, and these are required for podman. And then finally what you'll see under here is we have the podman anchor and the table. So all these have to go in the correct place. You can't just stick them in willy-nilly. As I said, the PF configuration starts off with the variables, macros and tables, as you can see here. Then we have the global policy, the NAT. Then we have the block. We've got more anchors here. And what we have finally down here is the traffic. And what we have set here is the pass on interface. And this is used for the TCP and UDP rules that we defined at the top of the file up here. So this is so that we can actually allow access to the container. So what you can actually do to make your life simpler is you can copy my configuration and use that as a basis to get started, because it's all working and it should save you a bit of head scratching. So that's the PF setup. Once you've got PF set up and you've applied the rules, you've saved the file, you would run doers service PF restart. Okay, so that's the PF. The next thing that you're actually going to do is you're going to create a data set with a mount point for the podman containers. So as you can see here, we've got doers ZFS create -o mount point var db containers zroot containers, and this is actually the location that is specified in the podman configuration file. So don't choose a different location, because otherwise you'll have to edit the podman configuration file, and it will just make things easier just to use the location specified in that file. So next thing is sysctl. What we want is we want to have net.pf.filter underscore local equals 1. So you can do that with doas sysctl net.pf.filter underscore local equals 1. And what you can do is you can edit your etc cyscsctl.conf, and you can add that in there. So let's have a quick look at that. So etc sysctl.conf, and the okay, right. There's mch root disable bell, user mount, default audio head output, audio tweaks, Chromium, change the responsiveness from server to desktop, screen brightness, bibs, and finally podman. So you'll see here we've got net.pf.filter underscore local equals 1 in our sysctl.conf. Okay, and then finally what we're going to do here is we need to add podman underscore enables equals yes, and we'll do that with doas sysrc podman underscore enabled equals yes, or you can manually edit your etc rc.conf and add that in there. So the next thing that we want to do is actually specify the registries, and this is a list of places that we can actually pull podman containers from. So what we're going to do is run doas vi user local etc containers registry.conf, and what you're going to want to do is add this code here. What you'll see is unqualified search registries. We've got docker.io, qwen.io, and ghcr.io, and you'll see each of those has a corresponding block here: registry location docker.io, registry location qa.io, registry location.ghcr.io. So as I said, this is so that when you run the podman pull command, or you're using a compose file, that it will actually pull from the correct registry. Okay, so what we're going to do now is actually create a ZFS dataset for our configuration files. So what we have here, I come in here, I have a podman directory in my home where I have the configuration files for the various podman containers. In this case, it's going to be searxng and mcp-searxng-enhanced. Okay, so what we're going to do is actually, instead of just creating a directory for these configuration files, we're actually going to create a ZFS container. So doas ZFS create zroot home your username podman, and then we're going to run doas chown -R your username home username podman, and what that will do is it will create a podman mount point for the ZFS dataset, and this is particularly handy if I run ZFS list. What you'll see here is I have ZFS datasets for all of the directories in my home. So like cache, config, local, ollama, bin, desktop, documents, downloads, git, music, pictures, podman, torrents, and video. And I showed you how to do that in a separate video where I covered the freebsd installation process and advised you to create the data sets after you finish the install. So, and before you actually set up a desktop or window manager, so that once you start up the window manager or desktop, all the files will actually be installed in data sets and you can roll them back, or you can mount the data sets to recover files. So the next thing that we're going to want to do is have DOAS set up. So install DOAS. If you've got sudo set up, you can run sudo pkg install DOAS, or switch to root with su dash into your admin password and then install DOAS. And what I'm going to do is actually just come across here. So that's user local etc doas.conf. What you can do is, first of all, we permit the user. So permit keep environment, set environment, path, the username. Then what we have here is allow root to switch to our user, which is something that you also need to have set up. So permit no path, keep environment, set environment, path, root as your username. Then what we have here is actually two sections. What you can do is you can enable DOAS so that it doesn't prompt you for a password for any command that you execute. And this is actually particularly useful if, like me, you use Emacs and you tangle files, or you edit files using tramp, because then it won't actually prompt you for a password. And the advantage of that is the tramp with Emacs can actually sometimes not get the password. The interface that you use with tramp and Emacs can sometimes fail on entering the password, which is really annoying. Let me have some tea. So this is to permit all commands that are run with DOAS to be run without prompting you for a password. But what you can also do is actually specify a single command that you want to execute without being prompted for a password. And the order of these actually matters. The last one sort of wins. And what we have down here is podman permit user no path. So we have permit no path, keep environment, username, command, user local bin, podman. So what that allows you to do is actually execute the podman command without being prompted for a password. And then finally, what we have down here is root as root. And you need to have this as a last rule. And this allows you to actually switch to root properly with DOAS. So that's the DOAS. And don't worry, I'll put links to all this under the documentation. Once you've actually got that set up, what you can do is run the hello world, that should say hello world podman container. So if I run that, give it a second, hello world. So that indicates that podman is properly set up and running. And note, we had to run podman prefixed with DOAS, because as I said, on freebsd, podman is not rootless, meaning that you have to run it as root. Okay, so you got to that stage, you got podman set up. Now the next thing we're going to be doing is actually setting up searxng. So searxng actually is a Linux container. So what we're going to be doing is actually pulling down two images. Now, searxng is actually set up with what's called valkey, which is a sort of server, and it uses Alpine Linux. And what I found is that FreeBSD doesn't like Alpine Linux containers. Okay. So in the documentation for searxng, it will actually tell you to pull down a Alpine Linux valkey container. But what we're actually going to be doing is pulling down a Redis 7 container using Debian Bookworm. And the reason why we're using Debian Bookworm was because I don't think there is actually a Trixie image available. So now this is the important bit here. We've got doas podman pull --os Linux. And this is crucial because we're pulling down a Linux container. And if you omit the --os Linux, you will get an error because we're on FreeBSD and it will get confused and try and pull down a FreeBSD image that doesn't exist. So what we do is doas podman pull --os Linux docker.io, which is one of the registries we set up earlier, library redis:7 bookworm. Once we've done that, we can actually pull down searxng by running doas podman pull --os Linux docker.io searxng latest. That will pull down the images. And the next thing that we're going to want to do is actually edit a couple of files. So what I'm going to do is actually take you through and show you here. So what we've got here is 4 files. We've got compose.yaml, limiter.toml, searxng-gen-key, which is a script that I knocked up to generate the key because searxng requires a sort of OpenSSL key to be generated for it to run. And then we have the settings.yaml, which is the configuration. So let's go through the compose.yaml. So what I've done is actually set this up so that it actually works correctly on FreeBSD. So another of the issues with using Podman on FreeBSD is a lot of compose files or Docker compose files will have Linuxisms in them to do things like drop the privileges. However, this doesn't actually work on FreeBSD because it basically, take my word for it, it just doesn't. So what we have up here is the version, the services, Redis, the image that we've pulled. So this is the Redis:7 bookworm. We've got the command here, Redis server. So the Redis server is used with searxng. And what you'll see here is we have restart and stop, network mode host, volumes val key. And then what we have down here is the searxng configuration. So this is the container name. This is the image that we were pulling. We've got network mode host, and this is so that it's going to actually use the host for the DNS. And what you'll see down here is volumes. So what we've got here, this corresponds to the dataset that we created, the ZFS dataset. So we've got home, podman, searxng, and that corresponds to the mount point that we created with the ZFS dataset. And what you'll see here is got searxng key, user local bin searxng key. And what that will do is that will copy this script and that I'm going to show you that creates the randomly generated string that's required by searxng, and it copies it from the current directory into user local bin searxng-gen-key inside the container. And the next thing that we have down here is the environment. So this is where you set the searxng base URL. So I'm just running this on localhost here, port 8080. And what we have is the Redis URL. Again, that's the localhost. And we have searxng secret equals searxng secret. And that is used with the gen key script so that it will generate a secret key. So rather than hard coding the secret key into the configuration file, which you wouldn't want to do because it means you wouldn't be able to push it up to GitHub, we create a script that generates the key and actually sets an environmental variable that this configuration file picks up. And then what we have down here is networks, searxng, volumes, searxng config, and val key data 2. And what I want to do is actually show you an important thing. So if I come into Podman, okay, let me just increase the size of this. What you will notice is the permissions on this searxng directory are tests and tests. Now the reason for that is because the UID that the searxng server runs under inside the container is 927, I believe. And because we can't drop the privileges as you would on Linux, what happens is it's changing the permissions on the directory and the files inside of it to the ID 927, which on FreeBSD actually corresponds to this tests ID here. So that's why it's saying tests. And if I list inside there, you'll see all of these files are owned by tests. So the one gotcha is that you need to be root to actually edit the configuration files once searxng is actually started up. And as I said, that is because we can't drop the privileges using the compose.yaml file, and that's just not something we can do on FreeBSD. There is a podman unshare command that allows you to sort of manipulate the UIDs, but that only works with rootless containers. So that's just something to point out to you in case you get confused as to why this is owned by tests, okay? All right, so these are that's the compose.yaml. This is the limiter. So this is the bot detection IP limiter. And this can be required for some things like if you set up open web UI, things like that to work with searxng. You actually need this enabled. And then what we have here is the searxng gen key script that I created. And what you'll see here is we have a variable searxng underscore secret equals. And what we have here is a subshell with OpenSSL rand hex 32. And what this does is every time you start up searxng, it's actually going to run this script and create a random 32-bit key and set that to this variable. So this variable searxng secret is actually referenced in the compose.yaml file, and this avoids us having to hard code the secret key into the configuration file, so that's really handy. And then finally what we have down here is the actual settings.yaml file for searxng. And what you'll see here is we have secret key double quotes and it's empty, and that is because we are setting the secret key using the script I just showed you. We've got limiter false, image proxy true. We have the Redis URL. You've got stuff like instance name, privacy policy. So these are these little settings down here are actually things that show up at the bottom of searxng. What will by default what will happen is you'll get an extra set of links for like things like donations, privacy policy, contact URL, and you can disable those links using this code here. Then what we have is the search section, so we can set the safe search to off. We've got autocomplete, and I actually, you can just, I've set this to no, but I actually set it to yes in the interface. So this is the autocomplete FreeBSD packages. So you can see here it's actually not auto completing for me. So what I actually want to do, let me come into searxng. So as I'm going to bring it down, podman compose down, go as vi settings.yaml, and where's the, we'll put autocomplete Google, save that, go as podman compose up -d, okay, and come back to here. FreeBSD packages should autocomplete now. With the preferences, yeah, it's set to autocomplete, so I'm not sure why it wasn't. So FreeBSD, FreeBSD package manager. Okay, so that's how we get the auto completion set up. Right, autocomplete minimum. So this is the minimum amount of characters. You don't want the favicon resolver. It actually slows things down. We've got the default language. Any other stuff here? These are sort of defaults, but this is the format section. And what you want to do is actually have HTML, obviously, because otherwise you won't see anything in the browser. So we've got HTML, CSV, JSON, and RSS. And what this allows you to do is actually download search results as CSV files. And the JSON interface is required for working with the mcp-searxng-enhanced MCP bridge that we will be using with our local LLM and ollama, or a online LLM like Gemini or Gemma 4, which I'm going to show you how to set up. And then finally, what we don't have down here is categories as tabs: general, images, video, news, IT, files, map, social media, and those correspond to these categories up here. Okay, so that's the configuration for searxng. And as I said, the way you start the server is by being in the searxng directory with the configuration files and running doas podman-compose up -d. And as I said, that is why you need the podman suite and the py311-podman compose file. And that is why we need the py311-podman compose package, because that provides the podman compose command that you will use to actually use compose files with podman. And to stop searxng, we just run doas podman-compose down. And when we want to pull the containers to actually update them, what we can do is just rerun the commands again. So we rerun doas podman pull --os linux docker.io searxng latest, and the same deal for the Redis bookworm container. And as I said, Alpine Linux, I think, is it something called MUSL? Is it like, sounds like muesli? But FreeBSD doesn't seem to like working with Alpine Linux containers in my brief testing. And this is how you can actually clean up containers. You can run doas podman compose up -d and then doas podman image prune -f while it's running, and that will remove the old containers. Okay. And as I said, this was my notes on the tests permissions on the searxng directory. And as I said, that is because the ID that is running inside the container is, I believe, 927. And because we can't drop the privileges, what happens is it maps those privileges from the container to the directory where we have our configuration files, and that is set up in the configuration. So what I'm going to do next is take you over mcp-searxng-enhanced. So what I've done is actually create a fork. So this is the original mcp-searxng-enhanced, which if we come into here, into the Docker file, yeah, this is the setup, and what it actually does is it uses requirements. Okay, so what it's actually got is a series of Python packages that it will install with pip. So what I have done is I've actually changed this. So if I come into the Docker file here, what you will see is up at the top, it would be easier in the in here. So Docker file. So what I've done is set this up so that it's actually pulling down a FreeBSD 15 image. So what we're doing here is we're actually building a FreeBSD podman container, and rather than using pip to install all of the Python libraries that are required, what we're doing is actually, apart from two Python packages that weren't available on FreeBSD, is we're installing all of the Python packages using PKG, and this speeds up the build time so that it doesn't have to build all the Python packages for FreeBSD, because I'm sure you're aware a lot of Python packages don't have a wheel for FreeBSD. So let's have a look through this Docker file that we got. So from ghcr.io, which is one of the registries we set up in the previous setup, we're pulling FreeBSD toolchain :15.snap, and that pulls down FreeBSD. And what we're doing here is, you may be aware that FreeBSD 15 has changed the way that you actually update it. So there are what's called the distribution sets, which is where you would update FreeBSD with FreeBSD update and FreeBSD upgrade. And when you set up FreeBSD, what you have to do is you've got to bootstrap PKG. So you may be familiar where you just set up FreeBSD and you've got to run user sbin pkg and it will bootstrap PKG. So what we're doing here is running environment, always assume yes, ignore OS version. So this is needed so that the container, if it is running a different version of FreeBSD than the one you're running on the host, it won't throw an error. And then we're bootstrapping PKG. Again, we're ignoring the OS version. We're running PKG update, PKG install, and then what we're doing is we're installing all of the packages that would be listed in the requirements.txt file that would be used with pip. So this speeds up the installation process. Then we have the work directory app. We copy the requirements.txt, and what we're doing here is we're using Python installed as the package with pip to install the two Python packages that weren't available as PKGs on FreeBSD. And what we have down here is the environmental variables to actually set the searxng base URL. So you can see here localhost 8080. We're setting the time zone to whatever country you're in. Europe, London. We have Python unbuffered, and this just helps on FreeBSD. So there is a few gotchas that I'm going to go through in actually using this MCP server on FreeBSD as opposed to Linux. Okay, we've got some other general settings here. Okay, and at the bottom, what we have down here is the command that is actually run when the container launches. So what we have here is user local bin python 3.11 mcp-server.py, and that is the Python script that actually sets up the MCP server. So I've gone through, and as I said, I've changed this from a Linux container to actually a FreeBSD container. And I originally did that to get around some issues I was actually having running the MCP server, a Sentinel error 126 with emacs gptel. And I'll show you how I actually managed to get around that by using a script with the MCP package for emacs. So that's the Docker file. This is the MCP server. And so what I've actually done is I've removed a little bit of the functionality from the MCP server. So the MCP server has a couple of tools that you can use. It can search the web, and it can also read web pages. And one of the options it has is to actually be able to read PDFs and then sort of convert them into Markdown for the LLM. But I've actually removed the PDF functionality because there isn't a package. Was it MUPDF, something like that, and there isn't a package for FreeBSD for that particular Python library. And to actually build that Python library on FreeBSD takes a lot of time. And so by removing that functionality that I wasn't actually going to use, it speeds up the build time so that it will build in the time it takes to go and make a cup of tea. So what I've done is actually removed the import for the PDF. And what I've also done is, if I come through here, PDF. So what I've done is actually change the if-else code for the PDF section so that it skips trying to render PDFs as Markdown. And what we got down here is the requirements. So if I come across to the requirements, so in the original version, what you see here in requirements.txt is these are all the packages that are installed with pip. Whereas what I've done is I've managed to cut it down to just 2 by using FreeBSD PKG packages instead. And so that just makes it take less time to actually build. So we're actually installing only 2 packages with pip. Okay. So what we're going to do is actually download the Git repository for the FreeBSD fork that I've created. So you'd run git clone and the command here, which links to the forked FreeBSD version that I created. And then you would change into that directory. And what you're going to do is run doas podman build -- network host -t mcp-searxng-enhanced :local . And the network host actually uses the network setup on the host. There is also a DNS option you can use. So you can put in a DNS server like 8.8.8 for Google, or I think it's 1.1.1.1 for Cloudflare. But as I showed you in a previous video, I have Unbound set up on this machine, which is a DNS server. And so by using this network host option, what will happen is the podman containers will actually use the Unbound DNS server setup on the machine. So the next thing we're going to take a look at before I actually show you this in action is we want to set up the MCP server inside Emacs. And what you'll see here is the use package MCP after gptel, and I'll show you the gptel code as well. It's called searxng, and what we're doing is the command is actually going to be a path to a script that I created, and what you do is you change username here to your username. And the reason for that is because, as I said, I was actually getting some errors, what's called a error in the process Sentinel 126 that I wasn't actually getting on Linux with the same MCP server and basically the same kind of setup. And so to get around that, what I did was actually create a script that will actually launch the mcp-searxng-enhanced podman container. And the reason for the error was sort of the JSON output, and the script actually sort of strips out the JSON errors that were throwing the Sentinel error in Emacs. So what we're going to do for the script is we're going to create a bin directory in our home, make directory -p /bin. And if you're using the ZSH shell, this is how you would add the bin directory to your shell path. If you're using another shell, you would do something similar by reading up on the documentation. And we're going to edit the ZSH env file. And what you'll see here is we have the section here on how we actually set up the path. So you can see here, path equals home bin, user local bin path. And what that does is that adds the bin directory we created to the shell path so that we can put scripts in that bin directory and they will be usable on the command line. Then finally, what we have is the mcp-searxng-enhanced script. So you'd copy this code and make it executable with chmod +x and the path to the script. And what you'll see here is this is a shell script. The shebang is bin.sh. And what we have here is force unbuffered output so the stream isn't delayed, export Python unbuffered. What we've got here is we're running the exe command, user local bin doas, user local bin podman, run irm network host. And these environmental variables, searxng, this is the path to the searxng port, so it's on localhost port 8080. And what we've got here is the container. So when we build the container, it's actually going to be called localhost /mcp-searxng-enhanced :local. And then what we're doing is we're actually piping that into grep line buffered JSON RPC. And what that does is that actually removes the JSON lines that would actually get printed in into Emacs that actually causes the error. So once we've got all that set up, what I'm going to do is actually take you through my Emacs init.el. So what we got here is the settings for Emacs gptel, which is a front end that you can use with Ollama and cloud models online. And first of all, what we're going to do is actually create a .auth info file in our Emacs directory. So let me just check. Auth info okay. So what we have here, thankfully it hides the password, is we have two settings that are going to be used with the Emacs gptel package. So what you can do is you can get an API key for Google that allows you to use Google Gemini and Gemma 4 on your local machine and connect them to searxng using the MCP bridge. And what you do is you put in machine generative language.googleapis.com password and put in the token that you get, and you get the token from AI Studio, I believe. And the other thing is ollama.com. If I come to Ollama, right, so Ollama actually has cloud models. However, I thought, oh great, I can use all these if I come to cloud. Okay, so you see here it's got things like DeepSeek Flash 4 Pro, qwen 3.5, qwen Coder, and it lets you create an account and get a key, an API key. However, the only model that I found that I could use without paying is actually Gemma 4. So if you want to use any of these other cloud models, you actually have to pay for them. So Gemma 4 was the only model from Ollama Clouds that seems to be free. So what we can do is, once you've got your API key from Ollama Cloud, what you can do is put in machine.ollama.com, login, API key, password, and your key. And so that is what is used with this auth source section here. You can also encrypt the .auth info file with GPT if you want, but I didn't bother. So what we've got next is the gptel package, and this is the package for Emacs that allows you to interact with Ollama, either running locally or with online models such as Google Gemini or Gemma 4 with Google's API key, or for free using Ollama Cloud. So what we've got up here importantly is setqgptel use tools, and that will allow us to use the MCP server that we set up. We've got the default mode, org mode, auto scroll, and what you can do is set the gptel default temperature. So as you may be aware, models have a temperature ranging from 0 to 10, sort of 1 to 10 rather, and 10 allows it more leeway in how it interprets things. So if you're wanting a more of a chat interface, you can have it set to 10, whereas setting the temperature to 0.1 makes it follow your prompt more strictly, which is probably what you want for things like coding and for searching using searxng. And what you'll see here is I've got 3 sections defined. I've got Ollama, so this is Ollama running locally. So what you can do on freebsd is you can install Ollama with doas pkg install Ollama. But note, there is a difference between the quarterly and latest branches. So the version of Ollama in the quarterly branch at present is 0.19, whereas the version in the latest branch is 20 point something or other. And that is important because it determines what models you can run. So for example, Google Gemma 4 actually requires version 20 of Ollama. So there is also, it's possible to only have 4 gig of VRAM, and I can't actually run the full version of Gemma 4 even when I was on a different operating system. So there is a gguf you can pull down from Hugging Face, and you can create your own model file that is smaller and actually fits inside of the 4 gig of VRAM. But I'm not actually using that because, as I said, that requires version 20 of Ollama, and that's not going to hit the quarterly branch till the beginning of July, which is the next release of the quarterly branch. You could use Poudriere to build Ollama from the latest branch to get the latest version of Ollama. But what I've got here is gptel make Ollama host localhost 11434, which is the port it uses. And what you'll see here is I've got a couple of models. These are, I never pronounce this, abliterated. And what that basically means is they have had the guardrails removed. So we've got qwen 3.5 2 billion. We've got the obliterated, excuse me if I'm pronouncing this wrong, 2B version and 0.8B version. So these will actually fit inside 4 gig of VRAM. And what I'm going to do is actually come across and show you my ZSH EMV. Okay, so the other important thing about Ollama on FreeBSD is that it doesn't use CUDA, it uses Vulkan. So the way that this works is I have a NVIDIA, was it 1650 card on my Dell XPS 15 2019 that's only got 4 gig of VRAM. And Vulkan is not tied to NVIDIA, so what it can do is actually use other devices on your machine. So I've got NVIDIA and a Intel card, and just using NVIDIA with CUDA gave me 4 gig of VRAM. Using Vulkan gives me access to the NVIDIA card and the Intel card at the same time, and that the NVIDIA card has got 4 gig of VRAM and the Intel's got 7.8. So combined, that gives me 11.8 gig of VRAM to play with. Now, in theory, this allows you to run larger models. I say in theory because in practice, what happens is, although you can run larger models than you would just be able to using CUDA, the issue is that Ollama is actually splitting stuff between your GPU and the Intel device. And what happens is, because of that, it's shifting stuff between the two, and it makes it extremely slow to actually even start the chat. So with like a larger model that's like, 7 or 12 gig or whatever, which in theory, as I said, you should be able to run. I've got 16 gig of RAM as well. Because it's kind of splitting the response between all these different things, it takes about 60 seconds for the response to come in, and the output is like about 1 or 2 words a second. So even though in theory I can run larger models, in practice, because the way that it splits the stuff between the various devices, it's too slow to actually be usable. But what you want to do in your ZSH EMV file, or the equivalent shell that you're using, is set export ollama _ Vulkan equals 1. And what this does is that makes sure that it's going to actually use your GPU, because otherwise it's going to fall back to the CPU, which you don't want. So that's how you get Ollama set up with Vulkan. So that's the local setup. Okay, so what you can do is, when you've got Ollama running, you run Ollama serve, and then you can run, if I come across to my notes, let me just check, is it Ollama? Yeah, this was the Gemma 4. Okay, so I'll put links to all of this, but this is how you can actually download the Gemma 4 gguf and actually create a model file. But as I said, that requires version 20 of Ollama, which is only in the latest branch. So if you're running latest, you will be able to run the gguf version of Gemma 4 if you've got low VRAM. and the only difference is it's text only as opposed to the full version of Gemma 4, which has got image and audio capabilities, which I tested on another machine and kind of wasn't really impressed with. Let me just see if it's actually okay. Yeah, these are my FreeBSD notes. So what we've got here is actually how you pull the qwen models. So we got the qwen 3.5, 2 billion parameters, and we've got the ones with the guardrails taken off, so 2 billion and 0.8 billion. So what that basically means is they've kind of been lobotomized to remove the guardrails, so they don't come up and say, oh, sorry, I can't do that. You know, I'm an AI agent. I can't tell you how to, you know, do X, Y, and Z because it goes against my protocols. Okay. So that's how you can pull down those particular models. Then what we have here is Ollama Cloud. And what you'll see here is we're running gptel make ollama cloud. And this part had me stumped for a while, is because what I thought is you would have to put in the ollama.com or api.ollama so that it would kind of connect directly to Ollama Cloud. The way Ollama Cloud actually works in my sort of brief testing is that what you actually do is, even though you're using a cloud model, you actually run Ollama serve locally, and that kind of acts as the middleman, and using the authentication files and stuff, it will actually kind of forward the sort of traffic to Ollama Cloud. And what happens the first time, if you do Ollama, you come across here, Gemma 4. So if I come to Gemma 4 here and Gemma 4 Cloud, what you'll see is it says Ollama run Gemma 4 :31 billion parameters dash cloud. When you run that in the terminal, so you run Ollama serve, and then in another terminal you run that command, what will happen is it will prompt you to log in and connect your machine up. And once you've done that, you'll be able to run the Gemma 4 :31 billion parameter cloud version from Ollama Cloud. And as I said, this is the only model that I've actually found that is free on Ollama Cloud. So that's the sort of setup with Ollama Cloud, is you actually need to have Ollama running locally by running Ollama serve, and then you can run the cloud models. And then finally, what we have down here is Gemini. So this is Google Gemini, and what we have here is set Q default gptel model Gemma 4 :31 billion parameters dash IT, and we have this code block that defines the models that we can use. And you'll see here we have, I zoom that out a touch, key gptel API key from auth source. That's the .auth info file we created. And the generative language Google APIs.com was defined in that file, and it finds the token. And what we have here is a list of models that we can actually use. So we've got a couple of Gemma 4s. We've got 31 billion parameters, 26 billion parameters. We got Gemma 3 flash preview and Gemini 3 flash preview and Gemini 2.5 flash. So what this allows you to do is, rather than going to opening your browser and using Gemini, you can use Gemini from within your client, which in this case is gptel. Okay, and we've got some other settings down here so that it displays the Ollama and Gemini buffers in the same window, and some other settings, okay, to silence things, and some tools that we're going to use. So once we've got all that set up, what we want to do is actually use the model. So what I'll do is actually take you through getting this set up. So we've got searxng. Let me just take you through. So let's bring that back down again. Doaz podman compose down. And what I've noticed sometimes is you actually need to start the bridge before you start searxng. So I'll do it that way for the demo. So what we're going to be doing is running metarex gptel, and I've got orderless here, so I can type gptel mcp. I'm going to run gptel mcp connect. You'll see it comes up with searxng. Press tab to select it, press return. Starting one MCP server, 3 tools added from MCP server. So now we've done that, we want to start up searxng. So we're in the searxng directory with the compose.yaml file. So doaz podman compose up-d. That starts that up, and what you'll see here is warning image Linux 64 does not match the expected platform, and that's because it's a Linux container running freebsd, and you can just ignore that. But what we can do is I've got searxng set up here with a keyboard shortcut keyword, so freebsd. Okay, so we've got searxng running. So what we're going to do is run gptel menu, and what you'll see here is this the interface. And what we want to do, I actually need to set the model. Need to reset the model, so I've actually removed a lot of these cloud ones. So Gemma. Okay, so what we're going to be doing is using Gemma 431 billion parameters IT. So that's where we set the model. It's set by default. It's just I was playing around with before I started recording and changed the model I was using. What you'll see here is tools 3 selected, and that is from when we set the MCP server up. If we press T, what we'll see is we've got these tools set up here. I also have a configuration, a file that actually provides an MCP server for emacs that allows models to actually communicate with emacs and search the documentation and all the different functions in it. We also have file system options. So if I press S, you can see these are the searxng tools that we have access to. We have get current date and time, and this is so that the it can work out, what's the latest results. We have get website, and this actually scrapes the content from web pages using a Python package, so that you can actually give it a URL and it is able to read the contents of the web page and sort of process it. Then we have search web. So these are the tools that we have access to here. And I said we got ones for Emacs and file systems. For Emacs, if I come into there, I've got stuff for loads of different things I won't get into now. But the this is where you can set the model. You can set the temperature, and as I said, it goes from 0 to 2.0, and in my configuration it's set to 0.1. We've got use tools on, and again that's defined in the configuration file. And some of these things here are particularly useful. You've got the ability to add a buffer as context or a file, so that you can actually open a buffer or a file and give that as context to the LLM. So now I've got that set up, I'm just going to run gptel, and what that's going to do is prompt me down here, user create a gptel buffer default Gemini. And what you'll see up here is we've got Gemma 4, 31 billion parameters IT. We've got 3 tools, and then we've got the prompt. So these are the prompts that come with the gbtel package, default program writing chat. So what I can do is I now have access to searxng using this model, so that I can ask it questions and get it to do stuff that it wouldn't normally be able to do, because models have a cutoff in their language, in their knowledge as to when they were built. So if it was built last year and you asked it for the latest score in a football match, it wouldn't be able to figure it out. So what I'm going to do actually is I'm going to save this buffer as a file first of all, and the reason for that is because you can, in case you accidentally close the buffer, it will allow you to save the file and everything in it, so you don't accidentally lose it. So I'm going to desktop gemini.org, and what you'll notice up here, we have this properties tray here, and what you'll see here is the gbtel, the model, backend, the system prompt, and the tools that are available. And what happens is once you actually run this, you'll get a thing here that says gbtel bounds. And if you close the file and reopen it, what you have to do is run gbtel mode, but that will throw an error because it's already got this bounds thing set up. So if you've closed the file, what you do is you actually delete the gbtel bounds thing, and then you re-enable gbtel mode, and it will carry on working. So what I can do is I can ask it the other advantages. You'll see here we've got the tools to find get current date time, get website, search web. And because we've got this saved, what we can do is use D abbreviation to auto-complete the tool. So I can say use the search web tool and find the results of the of Newcastle United's last find the result of Newcastle United's last match. Save that, and then you run Control-C return. And so what it's now doing is it's actually going off and searching the web, and what you can see here is the token usage. And so what it's doing, you can see here, get current date time. And so that's how it knows how it can actually figure out when the last match was, basically. So maybe this wasn't a good query, but it's going to carry on typing. Okay, Newcastle versus Brighton, May, latest score. Okay, there we go. Newcastle last match was against Brighton Hove Albion, May 2nd, which they won 3-1. The goals were scored by William Asula, Dan Byrne and Harvey Barnes, and that is spot on. So that is how we can provide web access to a LLM that we have got set up. And this, again, is particularly useful because, as I said, the LLMs have a knowledge cut-off point as to when they were actually built. So what we can also do is, let's come to FreeBSD Reddit. What I can do is I can ask it a question I can say, give me the text from the latest post on Reddit. So what I'm going to do is, you can see here, if I just open this up, we want the get website. So use you don't have to specify the the tool name. So I can just say, use the tools you have access to and find the latest post on and return the text. Control C, return. And what that should do is actually see it's using the get website tool automatically, getting the URL, and it's scraping the page with Python. Flipper lighters. Okay. Latest post is announcement FreeBSD 15 beta submitted by Graham Perrin, which links to the latest here. Let's check that. Yeah, so it's picking this one up here. Again, see Graham Perrin linking to the mailing list. So that got that right. So this gives you the ability to not only search using searxng, but to extract the text from a web page. So it will actually give it something to work with. So we've used Gemma 4 here. So what we'll do is, what I'm going to do is I'm going to close this and I'm going to show you how you can sort of reopen it. See, okay, so you can see there it's got the actual content. So what I was saying is, if I come back here and just kind of collapse all of that. So this is the GPTel bound. So at present, because we've closed the file, we have closed the GPTel buffer, okay? So what we need to do is we want to delete this GPTel bounds thing here, okay? And then run GPTel mode, GPTel chat restored, and we can now continue the conversation. But that is how, if you have saved the chat and closed it, you reopen the file, you delete the GPTel bounds, and you run GPTel mode, and you can resume the chat. And the nice thing about using Emacs as a interface for Ollama or LLMs is you actually have a structured output in org mode, as opposed to when you're using something like Gemini in the browser. It's extremely difficult to scroll back and find various bits of the conversation. Using GPTel makes it really easy. You've just got everything under collapsible headlines. So as I said, I showed you those tools. So what I want to do is I'll delete that now, and what I'll do is I will run GPTel menu. GPTel menu, and what I need to do here is, as I said, I want to use Ollama Cloud, so I need to run Ollama serve. Okay, hopefully this doesn't. Let me just bring that down, and what you'll see here, snaps that down a bit. Total VRAM 11.8 gig, context window 4096. So I can now cloud, and I removed a lot of these models, so I've just got this one here. Use tools, GPTel. Okay, this is now using Gemma 4, 31 billion parameters from Ollama Cloud, and as I said, that's the only free one that I found works. And so I could search for, okay, use the tools you have access to and find free links about magpie channel TV, and that's a YouTube channel about Newcastle. Control C, return, waiting, calling tool. And so you can see here it's calling tools, waiting, querying Ollama cloud. Okay, and it's spitting it out. So the advantage of this setup, as I said, we've got Google Gemini, and we've got Gemma 4 from Google using the API, which is free. Then as a fallback, we have Gemma 4 with Ollama Cloud. So having the Ollama Cloud as a fallback is useful in case we run out of tokens using Google. So what I'm going to do now is actually close that and run one of my local models. So gbtel menu -m qwen. So what I'll do, qwen, and what I've got here is qwen 2.52b and the obliterated version. Yeah, let's try that. Okay, gbtel. Okay, you can see here we've got the tools. We're using a qwen. So what I'll do is I'll just ask it a simple question, and I'll be specific. I'll say use the search web tool. Because it's a small model, you can search. Is it? Just saves that, actually makes things easier for the auto completion. Okay, so actually saving them is search web. Yeah, so it makes the abbreviation work better. Search web, bang, tool, and find the URL for the FreeBSD forum. Okay, there we go. So what I'm going to do is actually close Ollama because it used a lot of CPU, and I hope that's not mucking up the audio being recorded. So I'm going to close Ollama here. Let's kill it. So that's hi underscore AI qwen 3.5 obliterated 2.2 billion parameters, and that's about the limit of my GPU. So that's how we can have local Ollama Cloud, and Gemini set up, all using the mcp-searxng-enhanced MCP server to connect to searxng. And what you can do, if I come across to my clone version, repositories. Okay. So again, this is the fork that I created that is a pure FreeBSD container. And this is the best MCP server to connect to searxng. There is another one called mcp-searxng that is more basic, but this has the ability to actually specify the category that you want to search. So you can actually specify when you're writing a prompt, set the category to general or images or video or news or IT files, map, social media, or whatever. So you can actually get the response back for just a particular category. So what I'll do is I'll close that. Hang on, yeah, close that. So what I'll do is I'll use, right, okay. What I'm going to do is I'm going to close this. So GPTel, I'm going to set that back to Gemma 4, Gemini. Got the tool selected, GPTel. Save this. Let's talk gemini.org. What I'll do is I'll put this article's is it called videos? Yeah, it's called videos. So videos. Okay. Use the web search tool, set the category parameter for videos, mandatory formatting rule. So we can say, for example, you know, here what we have is a title and a snippet. So we can actually specify the formatting. We can tell it not to use Markdown. And what we'll do is we'll search for Buster Keaton movies. We're going to say use the search tool, set the category parameter to videos. Search for Buster Keaton. We'll say find 5 videos. Find 5 videos. Five Buster Keaton videos or something. 5 Buster Keaton videos. What I'll do is I'll execute the, okay. So what I'll do is while I'm doing that, I'll come across here, Buster Keaton. I'll go to the videos tab and we'll see what it comes back with and compare the results that we get with the LLM. So what you'll see is we've got best of Buster Keaton's greatest stunts, 1 week, cameraman, cops, craziest stunts and scenes in color, greatest stunts, art of gag, cameraman. And what you see is these are slightly differently listed. So searxng has the ability to list stuff in different formats. In the web UI, you can sort of set by, you know, any time, you know, that kind of stuff. But with the JSON interface, what you can also do is set it by score. So the score is the kind of relevance, which is picked up by the most search engines, as it were. So using the JSON interface actually gives us more ability to be more specific on how stuff is returned to us. So we can set it by score. So it will give us the top ranking results. So as you can see here, what we've got is the link and then the snippet here, and it even has the sort of, you know, little icons here. And these will all be direct links to the video. Okay, so have a read through the options here. And it said what I've got down here is if you scroll down to the bottom, this is the FreeBSD section that I've tagged on. So we're using a FreeBSD 15 image. I've replaced a lot of the things that were installed with pip directly with packages. I've removed the PDF support to reduce build time, and we've got a link to the documentation that I've actually been going through during this video on how to actually set up Podman, the packages that you need, the changes to fstab, you know, all the different things that are covered, setting up Linux PF, ZFS, sysctl, setting up the registries to pull stuff from. So yeah, podman on freebsd, really good. It said it gives us the ability to run not just freebsd containers, but also Linux containers. But as I said, it doesn't seem to like Alpine Linux, and I think that's because Alpine Linux works differently from regular Linux. I think it's something called musl or something from memory, and FreeBSD doesn't seem to like that. There may be issues with some containers that use systemd. I'm not sure that. I think there's been some advancement. It uses something called OCI jails now, Podman containers, which is installed with the Podman suite. That because it's basically to do with like the PID one and all that kind of stuff. So I haven't tried a heavy systemd kind of thing. Actually get it working, but I did play around previously. You can see down my notes. I'm actually playing around with setting up Ubuntu, and you can do kind of stuff like mapping. In the past, what I've done is actually set it up to map the audio and sort of Wayland display from a container, so that you can actually have a graphical application running in a Linux container that you can launch from FreeBSD, which kind of might allow you to do interesting things like install Linux applications in a container and pull them down on FreeBSD and run them and have audio and video coming up in a Wayland window, that sort of thing. I'll put links to all this under the video. But yeah, that's how you can have your own private search engine. So general images. Nice thing about this images thing here is the if I click on this link, what it does is it actually links to the full image. I think I've just picked one that's particularly large. Let me pick one that's not quite so large. There we go. So it actually links directly to the image. And what you can also do on Firefox is if you save the page, you save as web page complete. Yeah, web page. See, you've got these options: web page complete, HTML only, or text all files. If you do web page complete, what it'll do is actually save the HTML page and all the images into your downloads folder. So if you're searching for something, you can download all of these images directly, and as you'll see, what you get here is you get download results. So you can download a CSV file. Oh. Okay, I think that just may be because it didn't like the because it's got so many images and stuff. Trying to download the CSV didn't like it, but if I come across to this one instead, download the results CSV. So this is a CSV file. So you've got title, URL, content, host, engine, score, and type, and you've got all the search results in a CSV file, which is useful. You can import it into something like Google Sheets, that kind of thing. There are also options for pulling things from different pages. And what I'll do is okay, it's another thing I was working on. Okay, just the one. Okay, no, Copy the wrong one down. It's the one I want. Okay. mpc-searxng-enhanced. Okay. What I'm going to do is I'm going to change this to freebsd. And what I'm going to do is run Control-C here to refresh the local setup. And what we have here is a org file. And this is the usage. So what you have, I'm sorry. What we've got up at the top is header arguments, page 1, the query, okay? And what we have down here is a no web code block. So what we're actually going to be doing is, because searxng has a JSON interface, we can interact with it using curl. And what we can do is, Emacs has something called org babel. And what this allows you to do is actually run code blocks and have the output back into Emacs. So what we're going to actually be doing is running multiple no web blocks. So we're going to be running code blocks that reference another code block that runs another code block. So what we have here is a code block that is using curl. It's connecting to localhost 8080 search. It's data URL encoding the query. So Q equals query. And the reason why we data URL encode it is because suppose this was FreeBSD packages. Okay. When you have a space in a web search query, it is replaced by %20. And obviously you don't want to write your query as FreeBSD %20 packages. So what this data URL encode does is it automatically converts spaces to %20. We've got data format JSON, the category, the page number, language, time. Okay. Let me just collapse that. Then what we have here is we have additional code blocks. Okay. So this code block up here is called, the name is searxng curl. Then what we have is another code block here, and you see it says searxng curl. And basically this is a placeholder, and what it's doing is it's the equivalent of typing out all that code. But we don't want to repeat the code multiple times, so we can just define it once and reference it. And what this is doing is this is calling the different categories, and it's piping the output as the curl JSON command into JQ and actually formatting it. So what we have is these additional code blocks for all of the different categories like general, image, video, news, IT, files, map, social media. And what we have down here is two sections. We've got search and results. So what you'll see here is these are code. So we've got three code blocks. We've got search code block, and what you see is name general search, and it's calling general no web. That's then calling general no web here. It then calls the searxng curl web. So what we can do is we can execute the code block here. Right. What this is going to do is it's going to take the query we've got set up here, FreeBSD. It's going to call this code block, then calls this code block. So we're running curl to the JSON interface with this query here. That is then used by this to pipe it into JQ. And what we can then do is, typically what happens is when you execute a code block in Emacs, it'll output the results directly underneath. Okay. However, what we can do is we can have this results thing here. See results general search. So if I execute this, what you'll see is now under the results, we've got the general results here. FreeBSD, Wikipedia, what is FreeBSD actually? Think again. Okay, so these are the results. And what you'll see is the output. We've got a number, the title and URL. So this is a link that will open. Okay. We've got the snippet. What we also have is the score, category, the engine. So what you'll see up here is you'll see the engines here. You don't actually see the score listed in the web UI, but the code that I've got set up actually ranks these results by the score. So we've got the FreeBSD project, Wikipedia. We've got all these results coming down here. And these are in collapsible code blocks. So what I can do is, because we've got the query defined up here, if I wanted to change the query, I'll just edit it and run Control-C on this header up here. But what I can then do is I can go, say, video. We'd come into so this is the results. We'd come into the images here, or the video, Control-C. Okay, that took 1 second. Come into the results, come down to video, bang. And what we have here, is FreeBSD in 100 seconds, the date, the author, the snippet, the time, and the link to the video. And so what we have here is FreeBSD in 100 seconds. We've got the snippet, we've got the length, the published date, the author, the score, category, the engines, all coming through here. So this is another way we can actually interact with searxng. And what you could then do is actually give this file to the LLM to actually go through and process. So I can do the same thing for all the categories. I could come through to images, Control-C. Right, 3 seconds. And what I've done is, this is not using async, asynchronous. So if you use asynchronous, you can get an error in the process sentinel. So if I come into images, what I now have is a list of all the images. So a direct link to the image, the resolution, the file size, the score, the images. So what this allows me to do is actually order the results in a way that you can't in the browser. So you could also sort the ranking by resolution, file size, other stuff like that. But what you see is, if I open this, it links directly to the image. Okay, and then just save the image. Give that a second to load up. So there's all the images. I can do the same thing for the results. As I said, we got the searches, which are where we search, and then we got the results. So what I can just, if I want to come down here, I can just delete those. So they're collapsible. And what I could do is change the query to something with a space in it. So emacs gp-tel. And what you need to do is run Control-C on the property. Local setup has been refreshed. Now if I come into the search results, run that again, come to the results, bang, it's giving us results for emacs and gp-tel. Okay, ranked by score, category. So we got the link, the snippet, the score, the category, the engine. Max gp-tel. Okay, so this is pulling out the link, the snippet, the engines, and as I said, because we're using the JSON interface, we've got access to stuff we don't have in the browser, like the actual score, which is how relevant the search result is for this particular sort of query and stuff like that. So that's another thing that I've been playing around with, that I'll link to, a way that you can actually specify a search query and return the results for the different categories up here, all into a text file. So we've got the search, we've got the results. Let's say the results. It's also set up so that it should append results. So this is the first page. Okay. What we can do is we can actually change the page. So this is the first page. We can change that to 2. Run Control C again here, and it will return the links from the second page. And this is particularly useful for researchers. It allows you to research a topic across multiple categories, have the output all in one file like this. And then what you could do, as I said, is you could take these results. What you'll see here is I've got this results export. Okay, so let's have a look at this. Select tags export, and we've got export on the results. So what does that do? So if I run Control C, Control E, what you see is we've got this section here, export scope buffer. So if I press Control S, it's going to say subtree, right? What that means, it's only going to export the results subtree. So we don't want to export all the code, we just want to export the subtree. So what I can do is do HH bang, and what that's going to do is actually export the results as an HTML page. So if I now open that up, bang, we've got all the results. Okay, so we've exported the results of our web research. You see we've just got the general ones here and not the image and all these other ones, but we've got the search results as a HTML page with all the links. And what I'll do actually, while I think of it, is I'll just delete that and I'll show you the images. So let's change this to count duck. Let me just check the spelling's right. Duckula. You may remember this back in the 80s, voiced by David Jason from Only Fools and Horses. And what we can do, we change that search query, Control C, Control C. And what we're going to do is we'll just delete that. And what we want to do is do a search for images. Okay. And again, what I'm going to do is the way we run Control C, Control E, Control S, change that to subtree, HH, bang. Okay. Right. Okay. It's failing on that. Maybe because that should have. Okay. So why has that failed? Okay. Let me just try that again. That should have exported the actual links. Let me just check why that's not worked. Control C, Control E, buffer, HTML. It should actually export the. Okay, so it's decided to be funny now. Okay, what it should actually do is export all the images in the page. Control S, HTML, HTML. Bound to have one failure. Okay. Oh, there we go. There we go. Third time's the charm. What you can see is because the we get the direct links to the image, what happens is when we do the export, what it's actually doing is it's creating the HTML for around the images. You can see there's some particularly massive images here, but what we have is the link to the image, the actual image, the resolution, score, file size, all that kind of stuff. Okay, always good to have a success there. And we could do the same thing for the video. So let me delete that and show you the video. Don't need that one. So just remove that, and the way it works again is you change the query up here, Control C, refresh, come into the search, and it said rather than the results being appended under this section and intermingled with the code, because we have the results thing down here, results video search, that corresponds to this block. Control C, okay, Control C, Control E, Control S, HH. Yeah, that may just be a warning about my font setup or something. Bang, open it up, and yes, that one's failed. So let's try that again. This may just be an issue with it can be stuff like if there's like an emoji or something in there, that might be the issue. Yeah, so it may be that there's like an emoji icon or something in the actual results that I don't have a link to. I don't have a font installed or something like that. But yeah, that's basically another thing I've been working on for how you can sort of use searxng for search results and have all the search results output back into Emacs and then export the search results. Let's try. Let's just try general. Control C, Control E, Control S, HH. Yeah, so I'm still getting that issue. Can't quantify sort blocks. I'll have to look into why that's doing that. So this is going to just show the code again. We could also export to plain text or other things. Still going to throw that error. Yeah, so but you basically saw that it was sort of working before, and now it's decided to throw wobbly. But I'll put links to all this under the video. But yeah, so we've gone through and got a lot of stuff set up. We've set up Podman. We've installed searxng. We've got mcp-enhanced freebsd version. We've got gptel set up so that we can run either local models or models using our Google API key for Gemini or Gemma 4. We've got Gemma 4 fallback on Ollama Cloud, which again is free. And we've got small local models we can run as well, and give them all access to searxng to expand their knowledge rather than just having a cut-off point. And be able to do some pretty neat stuff that can come in useful. So I'll put links to all this under the video. read through the documentation. I'll put links to all my configuration files and whatnot. So yeah, it should be good to go. There's a little bit of setup to actually go through to get everything to this stage. But once you've got that set up, you'll be able to run podman containers to do some neat stuff. And I'll be playing around with podman a bit more and what's actually possible, because Beehive seems to be a bit broken in FreeBSD 15, and that was how I was actually previously running podman containers. There specifically seems to be an issue running Linux using Beehive, and I had real issues. I tried various methods using grub, UFI, VNC, and none seemed to work. It was all to do with a lot of even text-based installers. It just threw errors, 8H errors or 0 something or other, 07 others. But I just couldn't get Beehive to work, and using Podman is a nice alternative in some cases for using jails, because you have the ability to distribute the Podman containers, which you can't really do with a jail quite so easily. That I can think of a way where you can sort of configure a jail to sort of set up searxng and then share it and have someone pull down the configuration quite the way that you can with a Podman container. So this is kind of like distributed applications. You can create a setup and have people use the configuration files by pulling down the Git repo, building it, using sort of Podman compose, that sort of thing, and then be able to have the sort of applications running on FreeBSD. There is a FreeBSD searxng package actually, and I did try it a while ago and it didn't work, but apparently it's been fixed since. But I'm not sure how it actually behaves. So that's why I was actually using a Podman container, because I've got that set up on Linux and I could use the same kind of setup. But as I said, there are some differences about how sort of Podman sort of behaves on FreeBSD as opposed to Linux. So I've pointed those out. So, you know, if you get stuck, rewatch the video as you go along. As I said, you've got to use --os Linux. We don't have the ability to change the permissions, which is why you get weird stuff like, as I said, you can see this is all owned by tests. And that's because we can't drop the privileges and stuff in the container because we're running containers with root. So they're not rootless containers that you would run on Linux. So there is a couple of bits of difference. But hopefully that will get you set up with Podman on FreeBSD, then allow you to start pulling down containers, building your own containers, either as I've done here, forking this Linux container and building it as FreeBSD, or using a Linux container here. And remember, there do seem to be issues with running Alpine Linux containers, so you'd want to switch to using something like Debian Bookworm. There doesn't seem to be a Debian Trixie Podman image that I came across. So that's just another thing to sort of bear in mind. And as I said, you may have to go through, if you have like compose files and they have things like stuff for dropping privileges, you may have to sort of edit the compose files a bit to remove those and get it working. So there was a little bit of tinkering about, but you know, that's FreeBSD, and that's why we use it, because we like tinkering around with things. So yeah, definitely worth exploring. Really opens up a lot of possibilities into what you can do on FreeBSD. And as I said, you know, we've got Ollama set up. But just remember what I said about ollama. The current version is 0.19 in the quarterly branch, whereas in the latest branch it's 20. And you need version 20 to run Gemma so having the ability to actually use the Google API keys to actually run Gemini and Gemma 4 in the cloud or ollama cloud actually lets us run more powerful models than we would be able to on limited hardware, such as I have, where I could only run like the qwen models, 2 billion parameters with 4 gig of VRAM. And remember, ollama uses Vulkan on FreeBSD as opposed to CUDA, and think that actually CUDA's broken again. So what happens is there's the mv-sgl run command, and what I was doing was when I was recording local share stations OBS. So what I was doing before with OBS Studio is I could use this commented out line here, which used mv-sgl run, and then launched OBS, and that would allow me to use CUDA with OBS Studio. But since the latest, is it NVIDIA SMI, since 595.5803, that was mv-sgl run NVIDIA-SMI. That shows CUDA version 3.2, but OBS Studio has actually stopped working with NVIDIA NVENC encoding. So I've actually switched to using Intel with FFmpeg VAPI, which uses my Intel card and is still hardware accelerated. But yeah, there may have been in like a latest commit for the was it libc6? I forget what the package is called. That provides the mv-sgl run command. But there seems, I think, looking on the FreeBSD forum, yes, these are my old posts. Yeah, here we go. NVENC code that does not load in OBS Studio, and apparently there have been some changes to the code, but they've not made it into packages on quarterly, at least anyway. So yeah, that's just a heads up that NVENC seems to be CUDA seems to be broken. NVENC recording seems to be broken with OBS Studio, and that's kind of the issue. You know, the driver gets updated, and then the shim's got to be updated. The stuff breaks. So that's why I'm kind of steering away from using CUDA on FreeBSD. And as I said, a lot of applications like ollama use Vulkan. Yeah, so remember, for ollama, you want to put export ollama _ Vulkan equal 1 in your ZSH env or equivalent shell file. Otherwise, ollama will use the CPU. So I'm going to go and have some more tea, and I'll put links to under the video for everything. And any questions, leave a comment, but you should be good to go and be able to get Podman set up and start playing around with containers on FreeBSD. So that's all for now.